let's kick off day 2 of the RNG Technical Symposium today on green energy and biogas. So I'm Paul Green. I run a biogas advisory business and I drive the biogas.tv website. In this session, we're going to hear from PAQ about deep hydrogen scrubbing from biogas. You can ask questions on the fly in the chat or in the Q&A box, and we'll spend a few minutes on questions at the end. Later today, you'll get an email from me pointing to the slides from this talk that'll be up on my website. Video recording of this will be available on www.biogas.tv by the end of the week. With that, I'd like to introduce Timur Dunayev. Timur is Managing Director and CEO of PAQ in North America, with close to 20 years of background in process engineering, specifically in anaerobic digestion. Timur is now focused on growing PAQ's North American business in both wastewater and RNG sectors. So with that, Timur, the floor is yours again.
Thank you so much, Paul. Always an exciting time to be here. Welcome, everyone. As Paul just introduced, I switched the gears from process to general management, but the process engineer inside of me will never die. And I'm extremely excited to present the ThioPAQ technology. I am a firm believer that as far as environmental biotechnologies go, ThioPAQ is probably the most exciting development in the past 20 to 25 years. So every time I talk about it, I get extremely excited to present both on the solutions and the biology side. So without further holding you back, let's kick this off. I included a couple slides from yesterday just to reintroduce ourselves a little bit. As of 2018, PAQUES is part of international Skion water family. Skion is a Germany-based company with more than 15 portfolio companies, and as of 2024, 1.5 billion euros in revenue. Here is the map of all the companies that are part of Skion Water, and we're very happy to be part of this diverse family of people in water and wastewater treatment and RNG space. You can see PAQUES right here with the headquarters in the Netherlands, but PAQUES as a business has representation across the globe. And today we're talking about our little part of the world that I represent, North America. I call it C2C, Caribbean to Canada, which is where we do our business. PAQUES has been around for a very long time and pioneered innovations in a lot of technologies. And today we're going to be talking about this specific one called ThioPAQ that started in 1992, and to date we have, I think, over 350 installations across the globe and over 65 just here in North America. Most of them are actually in RNG space. So this is, even though I still call it an exciting environmental biotechnology invention, this is now quite a mature technology with good representation across the markets. So what do we do here? In a certain sense, the scrubbing portion of desulfurization is exactly the same as you would expect from chemical scrubbing, but the nuts and bolts are around the recovery and regeneration of caustic related to H2S scrubbing. So let's dive a little bit into it. Everyone knows what H2S is. I'm sure everyone understands the challenges pertaining to H2S, depending on sulfate and or protein content in your waste stream and your substrate. You'll be converting it in anaerobic environment and into hydrogen sulfide, the most reduced form of H2S, and depending on your pH balance within the system, some of it is going to be in H2S aqueous form, and according with Henry's law, in balance with your biogas and driving the H2S concentration in biogas, and reutilizing biogas with H2S, and it can present a problem anywhere from safety to corrosion to the loss of efficiency. And so in most of the applications, especially pertaining to biogas reutilization, but also under Title V burning as well in the United States, because during the oxidation, it goes into SO4, the control of H2S is a pertinent topic, right? So as a technology, we take H2S and biogas and convert it into elemental sulfur in the biological form of elemental sulfur, and regenerating some of the things in the process. As I've already indicated, the chemical scrubber portion of Thiopac is a basic free-flowing media countercurrent chemical scrubber with a high pH desulfurization, taking H2S from gas and trapping it in the liquid form. And the media inside of the chemical scrubber are there simply to increase the surface area of the mass exchange, right? So, but what happens next is the interesting portion of it. Basically, what we do, we take the trapped liquid form of hydrogen sulfide in HS minus form, and then we convert it into elemental sulfur that can be removed. And in that stage, we also regenerate caustic that was trapping the hydrogen sulfide in the form of sodium sulfate, right? Sodium sulfide, sorry. And so the caustic gets regenerated, and that liquor, after we remove the sulfur, can be regenerated. Well, not can be, it is continuously regenerated for continuous removal of H2S from biogas. What we do with the sulfur afterwards depends on the size of the application, H2S concentrations, but the basic idea, we separate it from the slurry, and it can be separated in a liquid form. It can be pre-settled and thickened, and for larger applications, we even use decanter centrifuges to separate them up to 50% solids concentration in the form of biological sulfur cake, which is quite a good fertilizer to be utilized, especially for alkaline soils. And that's the summary of the overall process. So how does it look in the application, right? I think I started with this, but it's important to reemphasize that this is not just a biological invention. This is a well-established industrial process. So what we do is basically a supply of 2 to 3 separate parts that are then pre-assembled on site. Quite straightforward, right? Scrubber comes in, and then the rest of the equipment comes in either fully pre-skidded or even in a container, depending on the building availability and or climate, with the entire package control associated with it. So, so putting this on site is as simple as interconnecting the bioreactor to scrubber and to the skid and or container in a fully integrated system. There is no need for additional catalysts to be introduced. All of these bacteria are naturally occurring, so we're not generating and or devising any kind of bioengineered microorganisms there. As long as we maintain certain environment within the bioreactor, these bacteria will, bacteria and archaea will self-proliferate. To increase the speed of the startup, sometimes we bring biocatalysts from the existing installations, but that just to ramp up the process quicker. The biosulfur itself is a stable form of sulfur, right? Actually, arguably the most stable form of sulfur. Once it's converted into elemental sulfur, it takes a really long time to reintegrate it into any kind of solution, which is a big advantage. So you have a stable sulfur solution that you do not need to worry about. And in RNG applications, it's usually very, very simple to mix it with anaerobic or any other sludge or lagoon that you have on site. And that actually usually increases the fertilizer value of your digestate, right? And even if that is not possible, it can be sent to landfill as a non-hazardous solid. And so after concentrating it, it's actually quite relatively small stream. So it's a sustainable reuse of what would otherwise be considered a waste product. What are the main advantages of ThioPack? We, unless requested otherwise, can always guarantee less than 25 ppmv of H2S on the outlet of our scrubbers. And that is almost with any reasonable influent concentrations going in. What I mean by reasonable is I don't think there is any single application with H2S, especially in RNG sector, that is not going to be possible to be done by ThioPack. I would say economically, there is a low level cutoff at much, much smaller concentrations. It might not be economical, which obviously is every single technology we have our sweet spots. But I would say on the upper end, ThioPack is even involved in oil and gas applications at concentrations up to, if I'm not mistaken, 33% of H2S in the gas. Extremely high uptime, and that is thanks to our full integration of the packages and our control over the equipment, right? You saw those skids and you saw the photo of the container. Everything is pre-assembled, everything is FAT'd. All of the mechanical equipment is a reliable manufactured equipment within all of the US and overall North American standards. And we always can generate additional spares, on-shelf spares, or installed spares as necessary for the application. So really high uptime here. Very low operational costs, especially if you're anywhere above 100, let's say to 200 pounds of sulfur per day treated in your application. I think it's quite easy to show how advantageous it is to use it, even though if it's marginally higher on the CapEx side, the OpEx is really low. And the OpEx is really low because of the regeneration of caustic. So the only time you need to add the caustic into the system is not driven by the amount of H2S you need to remove, but simply driven by the conductivity of the water, just so you can continue absorbing H2S from biogas. Another thing that is extremely important, because we separate oxygen addition stage, which is still an anoxic stage within our bioreactor, from the scrubbing. There is no introduction of oxygen into the biogas stream. And that could, especially if you go to renewable natural gas into the grid, introduction of oxygen, depending on your CO2 removal technology and many other processes, can be complicating for the solution. And so no introduction of dilution air into the system or any oxygen into the system is also very advantageous. Fast startup, we bring these things up within a day once the biogas could be introduced. Really durable because of the chemical scrubber application, fast response to fluctuations, and I already highlighted the reuse of stable sulfur. The applications are everywhere, and I think I outlined this verbally, but this slide just summarizes this. As I said, we can guarantee less than 25 every single time, but if you need a little bit higher, we can integrate the system to be actually less efficient than it could be. And most of the time for the applications that we talk here in North America is the biogas and the landfill gases. And we have a very good fleet of installations in both biogas and landfill gas treatment. I started talking about these applications, but it's always good to see the differences. The smallest installation is like 10 kilograms of sulfur per day. I would say it's not the greatest, sweetest spot for ThioPack, but we can manufacture them as small as that, which is the picture on the left. And the picture on the right is, if I'm not mistaken, this is actually in Canada at the landfill, or a Vietnamese landfill. That's one of the two. I forgot what this specific photo is, but this is the largest application with 22,000 kilograms of sulfur per day. And you see that the components are exactly the same: bioreactor, scrubber, but obviously the sizes are completely different. Flexible design and manufacturing, important to note, again, for the RNG sector in North America, we can certify that upward of 75% is US manufacturing. In fact, I think that number is substantially higher, but some definitions become a little bit difficult to track, right? But every single component that we manufacture that we supply in North America is in the end assembled and manufactured in North America. Some of steel components for, I don't know, container, some of the VFDs and motors, let's say for the blowers, can be coming from abroad, but the final component manufacturing, engineering design, project management, everything is done locally in North America. Together with local project engineering and project management, I have a full fleet of field service engineers who are on the road commissioning and starting up these systems. They're located in the United States, covering from West Coast to East Coast, the entirety of our installations. And I think I keep on driving this point. I think I repeated myself multiple times, but I cannot overemphasize that even though we're an international company, the entire workforce and the entire back office support for North American business unit is here in North America. Over 30 years in the market, coming up almost this number is actually over 350 at this point, because as you can see, the latest cutoff was like 2022. And I can guarantee you since then we sold more Thiopacks, including in North America. Global presence, 62 is over 65 in North America, and I think that just highlights what we're capable of, and we have a lot of good references. Most of the time I say don't trust me, go ask our clients and people who we support. And actually I highly recommend people go onto Biogas TV website and watch an excellent video that Paul put together last year from one of our installations, and testimony directly from our client. All of that was extremely organic, no prompts whatsoever. Okay, I think I am. Yeah, I think I'm a little bit faster than I intended, but I think
this is good.
I think I was going faster, but this is the Q&A time.
This is, and our audience has had their coffee today. We're getting hammered in the Q&A button.
Love it.
A point that came up in the Q&A was many people are doing H2S suppression technique, like adding oxygen to the headspace or ferric salts into the digester. Do you suggest they continue to do those, or do you just want all the H2S to go to the Thiopac?
Yeah, every single technology has a space and application. I am a firm believer that both iron salts and microaeration have their own application that are specific to the customer needs. I would say that if there is, let's say, fugitive emissions and stuff like that, you would still want to implement multiple technologies at the same time. Every single technology has pluses and minuses, and I would say evaluate it on your own needs. I highly recommend looking into, so the criteria I would be assessing personally is how much H2S do you have, operational costs related to, let's say, mitigation inside of the digester, versus what you want to do in the bulk treatment. And I've seen the technology as being mutually exclusive, mutually beneficial, applied together, applied separately, and working for clients depending on their needs.
Okay. Can you speak to the question came about plugging? What could plug? Does anything tend to plug? Could you just kind of review again? So stage one is just a caustic scrubber. Stage two is a bioreactor. So can anything plug with solids?
The only place that has a potential of plugging with solids is the scrubber itself. There is two mechanisms of plugging. Well, actually, two general mechanisms, the way that a scrubber could get plugged. By the way, among over 65 installations, we only dealt with plugging once in a landfill application. Otherwise, every single other installation did not experience plugging. So the two ways it can plug. One is foaming inside of the digester if there is no good knockout pots before the scrubber, and then foam makes it into the scrubber. Happens all the time. If you've operated digesters, you know if it starts foaming, good luck to everyone on site. Yeah, they will be dealing with a little bit of mess. That type of plugging could get flush. We have flush nozzles on both the top portion and the bottom portion of our scrubbers. So that type of plugging could get flushed. The second type of plugging is the growth of heterotrophic microorganisms. So any introduction of carbon in egg RNG applications, that's usually not a problem at all because there is not a lot of carbon present overall. In landfill applications, we have to look into knockout pots, temperature swings, and stuff like that to mitigate that. But because we separate oxidation from scrubbing, that risk is majorly transferred to bioreactor, and in bioreactor there is basically nothing to plug because it's
Okay,
suspended system.
that's helpful. Okay. Can you talk about pressure along the way? So coming out of a digester, you're pretty low, couple of inches. Like
Yes.
where along the way do you need to boost pressure of the gas?
So as a technical solution, we can do everything with our scrubber. We have both control packages and materials of construction and specifications for anything from vacuum to highly pressurized application. And so we are completely agnostic as to where the boosting is going to happen. Um, our system overall only takes, let's say, 5 inches of water column and pressure drop across the scrubber. So that's technically all that we need. Most of the time, the pressure drop is related to nothing related to our scrubber. And as I said, we're capable of both accepting higher pressures and operating under vacuum. Whatever the solution is, just let us know how we can help with the specific
Okay.
application.
Okay. So how do you project how much new caustic do you need, right? So the caustic is all recirculated, it's closed loop. So if anybody's curious, like, okay, well, how much makeup caustic do I need? How do you respond?
We provide those numbers with every single budgetary and firm proposal, and we stand behind those numbers because they're empirically supported. I know, Paul, you've looked into operational data from these, right, with actual
Sure.
numbers. We projected based on the mass balance and knowing the conductivity that we need to stabilize based on the influent load.
Yeah. So the bioreactor is kind of a squattier, wider tank. Can you talk about the scrubber, how tall they get, how wide they get? Do you ever need to go to a second scrubber for big jobs?
We have never had to do a second scrubber. The scrubbers can get above 80 feet tall. So as long as there's no height requirements on site, and even with those, we've been able to accommodate so far in North America. So I've never seen height restriction limiting us. The width is directly related to the biogas flow. So the amount of
Yeah.
biogas that we're getting, and we're just obviously maintaining certain upflow velocities there.
But if 60 to 80 feet in height was a little bit much, could people do like a second one if they wanted to make sure that it wasn't?
Absolutely, we can, because actually, in reality, it's always designed as a plug flow, and so taking out and redirecting it into a second stage is no problem at all.
Yeah. So a question came in about permitting, SWIP permitting. So if you're on a dairy project and you have your sulfur sludge and you're adding it like into a lagoon, how do you see permitting questions come up about managing the sulfur?
I have seen permitting questions come up. There hasn't been a single time that we have not been able to address those. I think the most recent permitting question came from Kansas, if I'm not mistaken. That was, in my experience, one of the most, I don't know, people really dug into it, but it's a stable biological solids, right? So classifying them in principle should be no different than classifying digestate.
Can you speak to what the entry level CapEx is of a thiopoc unit?
Entry level capex is $950,000. That's a ThioPack 10 standard skidded package that is applicable for anywhere from 100 to 400 pounds of sulfur per day.
And so for folks that don't have this calculation written on the back of your hand like we do, if you want to get to pounds of sulfur per day, take your flow rate in SCFM, multiply by your H2S concentration in ppm, and the conversion is 0.00013. That gets you to your pounds of H2S per day. So I'm sure everybody wrote that down, hopefully, right?
Yeah, I'm smiling because Paul uses this all the time, and every time I forget to write it down.
Um, I don't know, Timmer, do you want to show the movie for 5 minutes? I mean, we have people's rapt attention. Is that
I love it, but
do
I
you
love it. Do
are
you
you
want?
are you are you bandwidth able to go find it? It's do you have because it's
You don't need to. I have it in my
okay.
in my
Let's show
YouTube
it.
highlights. Okay, let's see.
You know, the heavy stuff is over. Now we get to entertain people with a video. So I think the more sulfur, the better. And what we're seeing is ag projects have a lot of sulfur. Dairy projects, ag projects are wonderful for many regards, but the H2S is high and it's steady. So PAQUES is a slam dunk for ag projects. It's a strong answer. And so what Timmer's going to show you here is a video from an ag site in California that we visited.
This is 6 minutes 40 seconds. As you can see, it's marked in mine. I'm gonna turn the volume on. Paul, let me know if people will be able to hear.
And expand your screen if you would.
Is volume coming through?
I'm not getting volume.
So I can hear it, but I don't know if they can hear it. I'm just gonna play it, the video on it, okay?
Yeah. And you can paraphrase the owner's comments.
Yeah. So 5 separate farms combined. Actually, this application is where they boost it at high pressure locally, and then they send biogas from 5 different farms, and then the RNG is centralized for the 5 farms, and they utilize the ThiaPAQ technology. Actually, here's the drone. 2 years in operation. No issues from the system, and I'm summarizing what Adam is saying basically. And they're very satisfied with the removal rate. He's recommending ThiaPAQ unit. Brings tears to my eyes.
Yeah.
And so I'll skip. This is the ThiaPAQ process overview. This is the scrubber that they have. This is where the H2S capture happens by making pack column as I just described. And then we're going to, and this is the effluent. So actually the only space where biogas interacts with our system is in this column. Once the treated biogas comes out, it then follows through further into the system. And now they're showing the connection points of the lean solution for the recirculating the biological. And so the recirculation happens for the biogas scrubbing here. Now they're showing the bioreactor where the oxidation happens. As you can see, both of those things are sitting outside. And this is the ridge solution returned back into the scrubber where the H2S ridge solution comes in. This is the aeration header with where we provide air for oxidizing sulfide into the bioreactor. I'm going to skip through. This is the control panel that is sitting right here for the decanter. The decanter centrifuge was installed on the side because they have decent amount of load, and it made more sense. And you can see how the sulfur comes out from the centrifuge. I think, yeah, you can see how thick the centrifuge cake is here. And so it's very, very easy to to get rid of it. And then here they're discussing the controls and applications. Everything is fully automated, fully integrated into the control package with, as you can see, we're utilizing Andrews Hauser and Allen Bradley for the controls, which is the standard in North America. They're in the container. Everything is containerized, including the recirculation pump. And 10 hours per week labor is all it takes to operate this. And that includes the biological testing and maintaining the biology of the system. The summary is 99.9 H2S removal in this case, maximum of approximately 10 hours per week to run the unit. Highly recommend watching the video. As my middle schooler kids say, the introduction music slaps.
It slaps. That's extremely funny.
Any more questions here?
No. So I like how we have engagement from anonymous guests, and thank you for sending me the link. So it's in the chat. I don't think everybody can see the Q&A, so I just laid it into the chat. So not to be missed, and don't miss the slap and intro music. So questions come up a few times here on if you're getting 97% removal of H2S in the scrubber, is it frequently that you see some dry media beds installed in conjunction with ThioPAQ?
Sorry, I spaced out closing the video. Can you repeat that? Yeah.
Do you commonly see dry media beds installed in conjunction with a ThioPAQ just to get the final trace levels of H2S out?
Common maybe is not. I have seen plenty of applications where they install the beds, both for secondary polishing and as applicable. I know installations that don't require secondary beds, and I've known plenty of installations where, for example, they clean out trace H2S and trace amounts of VOCs as well.
How about as a backup for the bioreactor? Do you find the bioreactor's reliability is super strong, or do you find that the dry media beds are helpful in case you have any biological upsets?
Don't want to evade because upsets do happen. So I'm not trying to evade the answer, but I am a firm believer that this is application based. Because, for example, a lot of our clients, instead of diverting into adsorption bed, choose to divert to the flare, for example, in case of upsets. So there is many different ways to skin the cat. I would say I really like secondary adsorption installed as necessary, both for polishing and if you need to bypass. But there is a lot of different things depending on your permits, depending on your application. There's many different ways to do it.
Okay. So I think we're winding down here. We saw a bit about the daily operational needs in the video, but we couldn't hear it. Can you just recap what the key process parameters are that the operator needs to be watching?
Key process parameters are pH, ORP, and conductivity. That's the three. All three are fully automated. So they need to be watching for ORP inside of the bioreactor to make sure that we're not over-oxygenating and just oxygenating enough. That's all always on VFD and fully automated, but obviously monitoring this is important. They need to watch pH control, also fully automated, but obviously you need to check your chemistry level. You need to make sure your pH probe is calibrated on a regular basis. And the conductivity is we monitor so you don't oversaturate the liquid and your efficiency doesn't drop. As far as analytical testing, the number one is alkalinity, because alkalinity is actually the main reason you will be absorbing it and converting it.
Great.
By it, I mean H2S.
So thank you, Timur. We appreciate the presentation. ThioPAQ is a super strong approach to managing H2S. It is mature. It is very, very far from entry level. It's a great choice because it's robust and mature, and there's systems that folks can go visit. So with that, we will wrap session 1 here, and session 2 at the top of the hour is Mainspring Energy. Going to talk about power generation with linear generators. Great. So thank you, Timur. We'll let you run, and everybody go grab your coffee and come see us in 25 minutes if you would to hear about power generation with Mainspring Energy.
Thank you, Paul. As always, excellent organization. I appreciate it.
Yeah.